Well, good afternoon, everyone, or good morning, depending on where you are. I'm Kiki Klute, and I'm a principal at Earnscliffe Strategies based out of Toronto. I have the pleasure of being the moderator for today's webinar, a roadmap for decarbonizing Canada's chemistry sector. We are joined today by a terrific panel of industry leaders for an in-depth discussion on how to go about this important undertaking. Before I introduce our panelists, a few housekeeping items. You can submit questions throughout the webinar using the Q&A button at the bottom of your screen. We'll do our best to answer as many as we can over the course of the webinar. We are also recording today's session and we'll circulate it after. Without further ado, let me introduce our panelists. First off, we have Bob Masterson, who is the President and CEO of the Chemistry Industry Association of Canada, CIC, which represents Canada's chemistry and plastic sector leaders, including more than 100 member companies. Then we have Sarah Marshall, who is the Vice President of Sustainability for Nova Chemicals, where she is responsible for leading the company's long-term environmental, social, and governance strategy, managing the areas of climate care, corporate environment, and ESG reporting. Mike Burke is also joining us, who is the Vice President of Global Director of Climate and Energy for Dow Canada. Mike has been a senior strategist, sustainability expert, negotiator, and advisor in the energy sector for more than 30 years. Last but not least, Oliver Seldrick, who is the program manager with Clean Energy Canada. More importantly, for our purposes for today, Oliver was the principal author of the recent Clean Energy Canada white paper on decarbonizing Canada's chemistry and fertilizer sector, which caused a considerable stir within the industry. Oliver's white paper is also the motivation for today's webinar. So we are going to ask him to kick things off with an overview of the white paper and where it's meant to take us. Over to you, Oliver.
Great, thank you, Kiki. I'll just share my screen and we can get started. So hopefully everyone can see that. So thank you everyone for making the time to attend the webinar today over your lunch break for many of you. And I'd also like to say thanks to the Chemical Industry Association and Earnscliffe Strategies for all their work in developing and promoting today's webinar. We're mainly here today to hear from various voices in industry around the challenges and opportunities present in decarbonizing Canada's chemical sector, a critical opportunity for the employers and also for Canada's economy at large. Before we get to the panel discussion, I'm going to take a few minutes of everyone's time to just cover some of the research and the findings from our white paper that we launched in March. So to provide a brief overview of the sector and why decarbonizing is such a priority. Firstly, chemicals are in almost everything. By the industry association's estimates, some 70,000 everyday consumer products utilize chemicals or plastics and chemical processes, and they are in some way or another involved in 95% of all manufactured products, which is a scary statistic perhaps. Chemicals are obviously, as you can see, a major direct employer in Canada, but they also indirectly support hundreds of thousands more jobs across our economy. Chemicals are also a major export market for Canada, valued at over $41 billion in 2021. And despite being quite heterogeneous, and by that I mean very sort of varied in terms of the products, the company types, the processes being used, there's actually a relatively small number of large-scale industrial chemicals which are responsible for the majority of both the activity in Canada and also the related emissions, which is obviously the key point of today's discussion. And in Canada, that's dominated by things like ammonia, ethylene, polypropylene, and others. So in terms of what all that activity stacks up to, in 2020, Canada's emissions from the chemical and fertilizer sector produced about 21 megatons of GHGs, which makes it by far the largest of the heavy industries. And as you can see on my slide there, nearly on par with steel and cement combined. But to provide some additional context, it represents approximately 3% of the 670 megatons, which is our total national emissions for 2020. So those are some challenging figures, and I think that's again going to be the basis of today's conversation. But on the bright side, a couple of additional sort of points I wanted to flag. One is that thanks to our relatively modern facilities, Canada's use, or the industry's use of natural gas, primarily as a feedstock, and obviously Canada's regulatory environment, our overall intensity already compares quite favorably to international comparators. So on the slide, as you can see, it's 0.4 or 400 grams of CO2 equivalent per US dollar value of product produced versus 2.17 for China. There is the specific figure, and that's primarily or largely as a result of the use of coal, for example, as a feedstock in China. And then finally, and this is probably the most important bullet in this deck, and again, I think will underpin a lot of the discussion today, is that chemicals are not a sector of the economy that we are looking to phase out on the path towards net zero. Modeled by the International Energy Agency and others do see substantial growth even in a net zero scenario. And many chemicals and plastics and other combinations are ingredients in a lot of the technologies that will be needed to get us to net zero. So for example, chemicals in EV batteries and a range of electrified transport solutions, lightweight polymers and plastics in wind turbines, chemicals for the production of photovoltaic cells, solar panels, and there are many more, but those are just some really sort of high level obvious ones. So a sector that plays a key role in Canada's economy, one with substantial growth potential, even in a net zero world, but one that we need to decarbonize. And given the current state of technological development, the lifespan of some of these industrial facilities, which is quite long, 40 plus years in some cases, this is a process we need to begin rapidly and earnestly. So our white paper analyzed the current range of technologies and process shifts available for decarbonization, and we grouped them here in the 4 categories that you can see on my slide. And they very loosely, and to say very loosely, but align with where some of these emissions are concentrated, where they're coming from. So for example, electrification and fuel switching, you can see, addressing that can sort of help to sort of bring down a stationary combustion emission, for example. And a couple of things I want to note on this slide. One is that Canada already has an advantage in a number of these pathways. So for example, carbon capture, utilization and storage, or carbon capture and storage, requires the right geology to put that carbon and safely lock it underground. And this is something that Alberta in particular, for example, has in absolute abundance. If we look at shifting feedstock, one of the key feedstock replacement technologies in the future is predicted to be electrolytic or green hydrogen. And that's something that requires large volumes of fresh water, it splits water into hydrogen and oxygen, and a clean electrical grid, because if you run the electricity through it that's not net zero or low carbon, then you're not going to get the clean hydrogen that you need. But these are both things that Canada already has in abundance and is building on. In addition to this, some of these technologies, CCUS, hydrogen, they're also seen as really sort of, the chemistry sector is really seen as sort of prime candidates for some of these technologies. And I won't get into the details of the specifics, and I'm sure my panelists could certainly do that, but just the sort of way that a lot of industrial chemicals are produced make them really good test cases, demonstration opportunities for large-scale industrial application of decarbonization technologies. And then finally, I just want to note here that, as I mentioned at the top, it's a very heterogeneous sector, lots of different processes and approaches, different products, different chemicals. So these are not all the right pathways for every chemical production process. These are a basket of tools from which ideally and hopefully the right combination can be found. So moving on. So given the scale of the challenge and the tools that we have to address it, what next steps do we need to take? And really this slide, I think, is sort of a taster of the discussion that we'll hopefully have today. This slide is a summary of some of the recommendations that our report brought forward, but there are sort of a number of very specific policies and approaches that sit under these. For example, addressing the small number of large emitters, that going a long way. That might be where we would think about direct government intervention and direct sort of site-specific supports. on the overarching industrial strategy for the chemical sector. This is where we might look to co-creating roadmaps for decarbonization, setting goals and milestones. And this is something that has recently been produced for the cement and concrete industry in Canada, and something that other jurisdictions are also using for their own chemical sectors, the UK and Germany, for example. And then looking at sort of market and investment opportunities, there are sort of new tools that the Canadian government is thinking of bringing to the table, carbon contracts for difference, for example, to bring increased price certainty and increased investor certainty, for example. And on the private sector side, there's buyers clubs, international clubs, Mission Possible, and others that are looking to sort of coalesce around this idea of prioritizing purchasing lower carbon chemicals and other industrial products. So there's sort of a lot that sits under these, but this is sort of the categories that we brought forward. And I'll finish, I think, perhaps on this last point, which I think from our perspective and in writing the paper, what we thought was one of the most sort of salient points, which is that we need to be strategic here. We need to understand the opportunity, and that means also understanding where Canada's built-in strengths are, and touched on some of those around some of the technologies that were available in Canada that make sense and might not be as viable in other jurisdictions. And also taking calculated risks on the future, that it is ultimately in the long term going to be an economic opportunity for chemicals, for chemistry, and for the Canadian economy. So with that, I'm going to stop talking. I didn't time myself, so hopefully that wasn't too long. And I'll pass back to Kiki to move us on to our panel discussion.
Thank you for that, Oliver. That was perfect. I know that it couldn't be, it must have been difficult to distill such an immense and important body of work into such a concise overview. So thank you for that. But it's certainly given our panelists much to talk about. So again, just a reminder for our viewers that you can submit questions at any time using the Q&A button at the bottom of your screen. To get the ball rolling, I'm going to put the first question to Bob Masterson, who in his capacity as President and CEO of the Chemistry Industry Association of Canada. So you've heard Oliver's presentation, Bob, and you know what's being asked of your industry and its members. So my question is, where do you even start, given the enormity of the challenge before you? And more broadly, how is Canada's chemistry industry responding to the climate change challenge and the net zero imperative?
Yeah, thanks, Kiki. Thanks for the question. And let me just start first by thanking Ollie for his presentation, but also Ollie and the Clean Energy Canada team for this important and very factual paper. Ours is a very important sector of the economy, which Ollie talked about, but it's really overlooked as well. You know, you don't touch the products of chemistry, they go into everything else. So sector's also often not thought about at the level it should be. $90+ billion a year industry. So I think this paper is a good starting point for the conversations that need to happen with some speed and importance. And reverse your questions around. Let's start with, where is the sector? How's it, how's it responding? And I use two things. One is very positively, and the other's balanced. And what do I mean by positively? If you look at the companies in our membership, and these are mainly global chemistry companies, nearly every one of them has set commitments, ambitions that are fully in line with both Canada and the global objectives and the imperative for dealing with this issue. So it's a highly engaged sector. It knows what it has to do, and it's committed to doing it. The other part, though, is I'd say it's got a balanced approach. I mean, there are going to be, and we'll talk about this, there's going to be enormous costs to decarbonize this sector. They're going to weigh heavily on the bottom line. But on the other side, and Ollie pointed this out, this sector provides all the solutions for everyone else, whether that's about e-transportation, solar panels, wind turbines, the solutions that are out there, food packaging, food waste, agricultural issues. These are all solutions that the chemistry industry can provide. So there's a tremendous opportunity to offset those costs by thinking about the business opportunities as well. So the sector is very, very much in tune with both sides of that conversation. You asked the question where to start. I'll try to be brief. Look, I'm a student of public policy, and I've always believed the thing you have to do first is stop doing the wrong thing and start doing the right thing. What does that look like? It means we have to start, we think of the homes we build today. Why are we still building homes that are going to be net energy consumers and net GHG emitters 40 years from now? Like, shouldn't we be able to stop that now? So when we look at our own sector, we can count more than 15 global scale chemistry projects currently proposed in Canada. One of them will be talked about soon. Every one of those is envisioned as low carbon or net carbon zero from day one of operation. So the sector knows, and you see this from the very large global companies, their next projects will be net zero projects, and we have the opportunity to do that right here in Canada. So that's the first place to start doing the right thing. Let's make sure the facilities we're building for tomorrow's economy aren't adding to the greenhouse gas budget. At the micro level, though, you know, where to start, that's up to every individual company and every facility. And as Ollie said, it's an extremely heterogeneous sector. You need to look at what your chemistries are. You need to look at what your electric grid is. You need to look at what your geographic situation is and put all that into the mix and decide where are the right places to make those first investments. Canada definitely has a lot of opportunities here, but it also has some challenges, and we'll explore those. And then the last thing I think companies have to do, and they're already doing very well, is really getting a handle on what the scope 2 and scope 3 emissions are as well, and how they're going to manage those, because it's not just about emissions associated with their facilities, although that is the topic of today's discussion.
Thank you so much, Bob, and thanks for taking the first question. I know that's always the hard one. Sarah, you've been the Vice President of Sustainability for Nova Chemicals for almost 2 years, and you were the Director of Sustainability for 2 years before that. What kind of steps has Nova Chemicals taken in terms of decarbonizing, and how would you describe the path forward for your company?
Thanks, Kiki. Well, we're really pleased to have recently launched our new corporate strategy for Nova Chemicals that focuses on two of our most pressing issues. We're aiming to achieve a 30% recycled content as a percentage of sales and a 30% scope 1 and 2 emissions reduction from our 2020 baseline by 2030. So both recycled content and emissions reduction as part of Nova Chemicals' plan for the future for 2030. And that's on our pathway to net zero by 2050. So with those goals in mind, we've pulled together on the decarbonization front a significant roadmap representing all of our assets in Ontario, Alberta, and Geismar, Louisiana. We've studied all of our emission sources, and we've categorized our opportunities for decarbonization on that roadmap. Now, the industry has always been successful at being very efficient. And for the past 20 years, Nova's reduced our emissions intensity by 30%. However, we're now looking to decouple emissions from production, and that's the way to a net zero future. So with the roadmap I talked about, we're focused on continued efficiency opportunities. An example of that would be continuing to look at flaring reductions as an example. Additionally, renewable power is an important part of decarbonizing scope 2 emissions in the industry. And we're ramping up renewable power opportunities through power purchase agreements or direct renewable power opportunities in all of our regions. That allows us to pursue electrification opportunities, which means you can switch gas-powered or emission-sourced equipment to electric equipment backed by decarbonized power. So those are some of the earlier lower-hanging fruit moves, if you will, in our sector and that Nova Chemicals has identified. Beyond that, we need to move into more significant fuel switching opportunities. To Ollie's point, a lot of the emissions in the chemicals sector comes from stationary combustion. And what that means is you're burning a lot of natural gas to provide high heat to operations. So hydrogen is a really important solution that's available now, and we're seeing good opportunities develop in both Alberta and in Louisiana. So to Ollie's earlier point, Alberta has some natural advantages in carbon sequestration that allows for the production of clean hydrogen for fuel switching. Finally, we're looking at self-developed and new technologies to take our way through 2030 and beyond. And NOVA at our Calgary-based research facilities has developed a low-emissions ethylene production technology that we're taking to pilot, which is a really unique catalytic approach to removing the opportunity for stationary combustion to a catalytic process that lowers emissions substantially. I'll also talk later about some of the market opportunities we see in low emissions products. And just to put a point on what Bob said, Scope 3 emissions quantification is an important part of our roadmap now too, because the customer base is really looking for not only those emissions that are coming from our facilities and what are our reduction plans, but also what's happening in the upstream value chain and how we're reducing those Scope 3 emissions that are ultimately flowing through the supply chain to our customers and their customers.
Well, thank you so much, Sarah, for clearly mapping out the steps that NOVA is taking. I'm now going to throw it to Mike. Mike, you have been in the industry for more than 30 years, and I know that Dow is making some important strides. How would you describe what you've seen in your company's role in meeting the challenges ahead?
Thanks, Kiki, and I appreciate the question. So it's been a unique last 5 or 6 years within Dow and our movement towards net zero. Like many of the companies that Bob alluded to and Sarah with NOVA, we've got a commitment to completely decarbonize our entire global fleet by 2050. And our board of directors is kind of on point in that almost all new projects that are going to be developed need to have a net zero component to them. One of the projects, and I think we're probably first out of the gate, I would say, when it comes to some of the new technology that we're looking at getting into place to do decarbonize, is basically we've announced in October of 2021, so a little about a year and a half ago, we announced that we were going to have what we call our Fort Saskatchewan Path to Zero project. So we have a large facility in Fort Saskatchewan, Alberta. It's a polyethylene facility. We make polyethylene. We're one of the world's largest manufacturers of plastic. A heavy CO2 industry, as Sarah alluded to. We have a lot of fired equipment, and typically we've been using natural gas in our what we call our cracking furnaces to take ethane to ethylene. There's a unique story, and as part of the question about what we've seen over the last couple of years. We initially envisioned an expansion of our plant many years ago, 5 or 6 years ago. We were starting to do some engineering into that. We have made some inquiries into Alberta. At that time, they had an incentive program called PDP, Petrochemical Diversification Program. Then along came COVID. So everything kind of suspended globally for a couple of years. I think we're all familiar with that. It gave us an opportunity to take another closer look at our project, to retool, and basically to expand the project. And that was at the point where we decided, Dow and our board of directors, that this is an opportunity for us to really make a change in the industry, a change in the sector, to do a lot of R&D and quite a global scale. So in October of 2021, we announced that we would be doing our first net zero facility around the world. This is step one for Dow. As I mentioned, that we're going to be decarbonizing all of our global fleet by 2050, and we're going to be accomplishing that basically through fuel switching. So as my colleagues before me had alluded to, hydrogen is going to play a major part in this project, and basically we're going to be taking all of our fired equipment. And the advantage of this project is that not only are we going to be tripling capacity of our current production with a new facility, basically an expansion of our current facility, it'll be on the same location, but we're also going to decarbonize our existing plant at the same time. So this is a monumental step for Dow, and I think for the sector, in that it hasn't been done before. There's a lot of R&D and getting furnaces that need to reach the temperature and the size that we have fired 100% on hydrogen. We're quite confident in the R&D aspects of that. The advantage is that we're also looking at, one of the changes we've made is that we're also going to be decarbonizing our electrical facilities. So we have cogen operations on the site, and that as well is going to be fired off of hydrogen. What we hope to get at the end of the day, when we're completed construction and we're fully operational, is we'll be providing the world with net zero polyethylene. Plastic is still a major component around the world for a lot of sectors and a lot of industries and day-to-day household items. And that will enable companies that we sell to meet their Scope 3 emissions reductions. So we'll be selling them a net zero raw material for their production down the road. In a combination of fuel switching, we'll still be using CCUS. I'll highlight the fact that Alberta is in a unique position and that we've got a lot of facilities and a lot of opportunity for sequestration of CO2. So to decarbonizing our current facility, we'll be doing CO2 capture off of the existing equipment, tying that into the Alberta trunk line, and then sequestering a lot of the CO2 that's coming out of our existing emissions. If all goes well, our board of directors will make a final investment decision on this project in October of this year, and then we'll hit the ground running after that. It's obviously going to be a phased approach to building, but we hope to have phase one, if everything went well, finished by 2027, 28, and then all sectors and all phases completed by 2030. And from that, the other aspect I'll highlight is that this facility with Dow, we're looking at fuel switching to hydrogen, but recently Dow announced a project with X Energy in the US. So one of the other opportunities that we're going to be exploring down the road is for SMR, small modular nuclear, and looking at, instead of fuel switching through hydrogen fuel furnaces, down the road, we may be looking at transferring some of our facilities into electric cracking furnaces. The technology behind that is still, I won't say in its infancy, but it is something that needs to be done and needs quite a bit of work and research needs to be done on it. But we're going to be doing a project at one of our facilities in Texas, and that will look towards the future of manufacturing, and that will have the opportunity, depending on where we're at in the world, to potentially utilize hydrogen as our energy feedstock for heat and power, or SMRs down the road. So looking forward to the future.
Well, thanks so much, Mike, for outlining the changes coming from Dow and what we can expect in the future. Over back to Oliver, there's no denying the extent of the challenge before the chemistry sector, but there is clearly an opportunity as well. So given what you know from other sectors that have undergone similar transitions, what are likely to be the key factors to meeting the reduction targets ahead?
Thanks. Yeah, so I mean, we do Energy Canada, we, and in my file, look at heavy industry in the round, so we look at cement, steel, forestry, aluminum, and others. And I wouldn't say there's one sector that's necessarily miles ahead of anyone. I think, as Bob mentioned, it's perhaps an element of chemistry, not necessarily always seeing the products that you buy on the shelf or anything like that. But looking at, say, what's happened in other countries, other jurisdictions, I think steel is probably a heavy industry that's had a bit more coverage in the last few years. One of the things that we showed and I'll plug in another paper that we just published, which looked at decarbonization of industry across the G7, similar economies, similar sort of sets of challenges. And it was, great to hear from some of the organizations today about their, pushing these demonstration facilities, the application of, large-scale industrial sites that are really sort of committed to that, not just the lower emissions, but actually getting to net zero. And there are sort of, Germany, as I mentioned in particular, they have really kind of taken a lead on driving forward net zero steel and realizing that there are technology readiness levels for some of these processes that are going to take a while to get to where we need them to be truly competitive and being able to sort of scale to the needs that we have. Steel is another product that has a very sort of significant role to play in net zero. It's again not something we're phasing out. And I think linked to this is getting that, and we hear it from other heavy industry sectors, is this investor certainty. Decarbonizing these are large scale facilities, it's long-term commitments, long-term investments, substantial capital costs, and in some cases also, short to medium term operational OPEX kind of additional costs. So finding ways to create that investor confidence. And as I mentioned, I think in the deck, contracts for difference, something that Germany and the UK and others have looked at to kind of provide sort of fiscal mechanisms that can sort of support and just sort of give that extra catalyst to investors is something that I think is a good way to look at it. And then finally, and again linked to sort of investment and the sort of the market side, and it was again flagged that there are companies out there looking to get rid of their scope 3 emissions. They are looking to buy low or zero carbon chemicals. But that is a really key part of the equation. And again, what we've seen in other heavy industries, I'll pick on steel again, is companies like BMW, car manufacturers, doing long-term purchase agreements with low carbon steel producers and saying, like, we're going to be here, we're buying it, and it creates that loop, which is to say, if you make it, they will come. If we build it, they will come, and that's sort of closing the round on the process. So yeah, just some of the kind of pieces that we're certainly hearing from other heavy industries on how to address some of these challenges.
Kiki, if I may, just a couple comments, maybe one to help put the scope of the challenge in context so the audience can understand it. In Alberta, ethane cracking occurs at two very large facilities. And if you want to think about the amount of energy consumed, and so Oliver talked about, electricity and decarbonizing the electricity supply, maybe electrification of the crackers. Those two facilities alone, if you converted their energy use to electricity today, it would total more than a quarter of total electricity consumption in Alberta. With Mike's proposed expansion, you'd be close to 40% of current electricity production in the whole province going to these two facilities. So that's one set of challenge. We also have to think about the electricity system, but also another component that's very interesting. Oliver listed the 4 parts of the framework. Sometimes you have to put these two things together, because even if you crack ethane through an electric cracker, you still have CO2 as a byproduct. You're still going to have to do something with that residual CO2. You're still going to need carbon capture. So, scale of the challenge, but also how you put these pieces together is going to be important and probably unique compared to some other sectors.
Yeah, I could jump in as well, Kiki, if you give me a second. I was monitoring some of the Q&A questions, and there's a lot coming up on the hydrogen side, and in particular to some of the questions on my project. So basically, when you take ethane and you turn it into ethylene, you take C2H6 and you turn it into C2H4. So your rudimentary chemistry class, you're always liberating hydrogen. So one of the questions was, how are you getting this hydrogen? How are you generating this hydrogen? Basically, in the chemical sector, with our process, with Nova's process, you're always liberating hydrogen. We're referring to it as circular hydrogen. I mean, hydrogen has a number of colors: blue, green, pink. So we're just calling it circular hydrogen because as part of the process, you're always making this hydrogen. And in the past, we would sell it to other sectors and industries that required hydrogen for their processes that were adjacent to our facility, or we would mix it in with some of the natural gas to a specific percentage that our furnaces could handle, and we would burn it as a fuel source. What we've discovered, and through engineering over the years, is that we believe we make enough hydrogen that we could almost be balanced. So we, through basically taking the fuel gas, the off gas that you get that has a high hydrogen concentration in it, but purifying it to 98%, and then running furnaces exclusively off hydrogen, you're taking basically what was, for all intensive purposes, a waste, although we were utilizing it to an extent, and turning it into your feedstock that you could now use down the road to basically cut down in your energy requirements for pure natural gas, for methane, using hydrogen, reducing your CO2 footprint. It's kind of a unique and intricate solution to a problem that I think the industry's had when it comes to our high CO2 footprint, that we can basically take the materials that we're utilizing in the past, turning them into a raw material, a feedstock that we can then use to generate more product down the road.
Well, thank you so much, Mike, for jumping in, because I know that David mentioned my question's been answered. So that's excellent that you were able to do that. I'm going to now throw it back to Bob. I've heard you say that the industry's ability to meet its targets is no longer solely a question of environmental policy, but as much as climate for the sorts of investments that will be needed. Could you explain what you mean by that and provide some examples where Canada, being an early mover, might bring some opportunities for Canada's chemistry sector to lead the journey?
Sure. And for me, this is the key point, really. It isn't about environment policy. Everybody's nodding vigorously. This has to be done. This can be done. It's a question of investment policy. Again, scale. Our sector in Canada is a $90 billion plus a year industry. A rough estimate, $300 billion of built chemistry infrastructure in Canada today. It's a rough estimate, but let's say it's in the 11 figures range. To get to net zero, we have to recapitalize every penny of that pretty much over the next 25 years. Possible? Maybe, possibly. But let's look at what we've done in Canada the last 20 years. We've attracted 10 billion, maybe 12 billion of new investment. So something radically has to change. And what has to change, and you see this in even the government's own reports, we have to radically change our ability to attract capital into Canada. if you look at another way too, I said, the global industry is committed to this journey, and I know it was one of the questions. The question is just where are they going to place these investments? Well, things aren't looking too great in Europe. And when you look at that suite of solutions we have, many of those are not present in Europe. The industry is growing increasingly cautious about its ability to invest in China. So you're back looking at a very positive North American future for this industry. We have the resources, we have the ability to mitigate the emissions. The question is, where will those capital investment dollars go? Certainly Canada was looking very good until about a year ago, and then the Inflation Reduction Act in the US really was a game changer. And suddenly, where we had these 15, nearly 20 projects proposed in Canada, most of those, and I won't put Mike on the spot, but I'm sure almost all of those went through a review process and said, well, wait a minute, does this still make sense in Canada, given what's available in the US? So I think Canada, and we'll talk about it perhaps later, with Budget 2023 has made a positive response. It's a material response, but there's no question the US is in the lead. If over the next several months, couple of years, we can get several of these projects to final investment decision, just like we're seeing in the steel sector, just as Ollie proposed in the cement sector, if we can show we can do this in Canada, Canada will have a tremendously prosperous future for the chemistry sector. If we can't get these projects to final investment decision, they will go south, and we will suffer in the long term because of it. So that's the key challenge. We got to get the investment policy right so that these multi-billion-dollar investments, Mike, you didn't give a dollar value, I know, but we're at least $6-10 billion plus for that one project alone. We've got to be able to attract that level of capital into this country for these projects.
Yeah, Bob, if I can jump into your contrast between Canadian policy and US policy, the IRA is just really simple to understand. And it's funny, we're all in the chemistry sector where it's inherently a complex industry. We're used to dealing with complex equations. But when it comes to piecing together the tapestry of everything that needs to be true in Canada to reach a comparable level of government support, the carrots and the sticks, etc., it is a much more complicated piece of calculus. And there's much less certainty when you're talking to your investors who may or may not be located in Canada to really understand what the long-term potential is for that. So I think the government is doing some good things to continue to look for ways to provide certainty to Canadian heavy industry. Ollie mentioned some of those already, and I won't get into all the details myself here, but I would say that what the US has done on a combination of economic and energy policy first is simple for business to understand and bank on. And that's an opportunity we have here to improve.
Thanks for that, Sarah. And your company is making some important moves as well on the environmental side. Can you tell us about some of the market opportunities you see in terms of reducing emissions and where you see the market trending right now?
Yeah, absolutely. One of the things I mentioned at the beginning was we have an ambition to achieve 30% recycled content as percent of sales by 2030. And I noticed some Q&A questions that were like, well, wait a minute, how does that relate to emissions reduction? So I want to close the loop on that. Nova Chemicals is in the business of manufacturing polyethylene, which is one of the largest used plastics globally. And so we're working on the twin challenges of circularity and decarbonization. And ultimately, we believe in a future where both of those things need to be true. Plastic waste can't be going to the environment. Minimum standard, we should be looking for all the opportunities to bring that product back around and use those molecules in play again to create new plastics from the plastics we have. When we look at mechanical recycling, which is a technology that's here and now, we're mechanically recycling many types of plastics in Canada today. Mind you, we can do a better job of increasing that. The scope 1 and 2 emissions of mechanical recycling versus what we know of our virgin plastic production are only about 10-15%. If you look at the product carbon footprint, which includes the upstream scope 3 component of mechanically recycled products, they're only about 30% of virgin plastics. So there is a benefit not only to circularity, but also to emissions reduction by using those materials again. Of course, as we decarbonize new plastic production, we'll be leveling the playing field there as well. But there's certainly an opportunity that we see in the mechanical recycling side and bringing more of those products to market, with particularly the specialization that Nova Chemicals and our teams of R&D folks bring to the table to help mechanical recyclers make higher quality products that can be used in packaging and that can be used also as a component of making packaging recyclable. So those are some of the things that we're working on in terms of market opportunities. I won't spend much time on sustainable plastic market opportunities for the future, like electrification and automotive and supporting the whole electrification of the economy. Plastics play an important role there, but I'll leave it at that for now and let some of the other panelists jump in.
Awesome. Thank you for that, Sarah. Now, I don't think we can have this conversation today without talking about the global economy. So, Mike, notwithstanding the human cost of the recent pandemic, the global economy is now dealing with the aftershocks and facing some potential serious economic headwinds. We are also seeing some larger economies make some significant moves. For instance, Bob mentioned throughout the US Inflation Reduction Act, or the IRA, and the huge amount of spending that's gone with it. How do you see the current economic realities impacting our ability to meet these targets that the industry is facing?
So a good question. And yes, I think Sarah and Bob and everybody mentioned the IRA and the US. So our project, we don't have the final dollar value in it yet, but I'm comfortable saying it's going to be north of about $10 billion Canadian. We're under pressure from our board to get those costs down. But and Sarah highlighted something, and I chuckled when she mentioned it, about the complexity of dealing with the Canadian incentive programs that we have in place. So the IRA in the United States has changed the world for investment. I think one of the things that the United States does incredibly well is that they recognize that these long lead industries, our facilities in the petrochemical world, they typically are built for 30 years and most of them run for 50 years. So when you invest in a project in Canada, our facility, Nova's facility, these multi-billion-dollar facilities, they run for decades. So the opportunity to get these in and to get the economy moving, and the advantage that Canada has is that we can be a world leader when it comes to CO2 reduction. We can be a world leader in sustainability. But the irony is that you need to get the investment in Canada to be the leader. These facilities will be built. Plastic consumption exceeds GDP every year. The world and plastic is a key element in reducing the global CO2 footprint. They make things lighter, they last longer. It's an inexpensive material to produce, and it has a much lower carbon life cycle footprint than most of the other alternatives. And these are the realities of the sector. In looking at our project, we have not made a final investment decision on it yet. To Bob's comment, Dow is taking a very deep look into what the economics of the IRA means to an investment of this size. Canada lost out in 2008 when we built our last major expansion. Canada was very much in the forefront. But we ended up building what we call Texas 9 in the United States because they had an incentive program in there that improved the economics of our project. They got the investment. They now have a facility that's 30 years plus that's going to be operational. And they get the opportunity to do a lot of R&D in the plastic space in Texas. We don't want to lose out on that again. I was very pleased when Canada came out with the last budget, some of the investment tax credit opportunities, because you have to understand, as I mentioned earlier, this facility is going to be built somewhere. We want the newest and latest and greatest technology to be in Canada. We also want the long-term economic impact. Alberta has a great program with APIP, the Alberta Petrochemical Investments Program. We are negotiating with the province of Alberta. We are also negotiating with the feds. The difficulty, and Sarah, I think, was quite eloquent in the way she phrased it, in the United States with the IRA, it's laid out very clearly in black and white terms. If you do this, you will get that. Unfortunately, in Canada, at the federal level, that's not really the case. There's still a lot of ifs and ands that need to go into it. It is a difficult process to weigh through. There's long-term commitments that you have to make. And the dollar value, I'll be very upfront, is not equal to what you could get in the IRA in the United States. Canada is getting close with some of the new investment tax credit opportunities that they've announced in the last budget, but these are currently unknown. There will be periods of public comment over the summer to kind of fine-tune some of those tax credit opportunities when it comes to hydrogen, CCUS, potentially green power down the road. The difficulty is that companies need to make a decision now. So we can't wait. We hope. Hope is not a strategy is one of the famous quotes. And we need to know when we make a multi-billion-dollar decision that this is pretty much a guarantee. This is what we know we're going to get. The difficulty is federally with some of the programs is it's still very much a negotiation process. And at the end of the day, depending on the dollar amount, it still has to go to the Senate and it still has to go to a minister that can say yay or nay. So basically, up until you have your contract signed, you're very much in this negotiation phase. And as a company that works on building our economic model for this project, we can't put anything in the model as a benefit unless it's an assured benefit. So you have to do a lot of risk profiling when it comes to some of the programs you have in Canada. Not to disparage any of the programs that we currently have in place. I think they are fantastic. They are ones that we definitely are going to look at utilizing for our project. But we really need to make sure that we don't miss out on these investment opportunities. You can't tax your way out of a recession. You can't tax your way out of tough economic times. The only way for a country and an economy to do well is invest. And we want to really attract some of these new technologies. We really want to look at decarbonizing the grid. We want to look at increasing our sustainability and circularity. We want to tackle plastic waste in the environment. All of that comes with these investments. When you look at tripling polyethylene production, Sarah is well aware of this. Sarah and I work closely on many panels and many projects together, but as competitors, but also as colleagues. The reality is our sector is screaming for recycled plastic material. Companies that we sell to want to have that 100% recycled label on their product. Decarbonization goes hand in hand. So at the end of the day, our goal, I think, for everybody in the plastic manufacturing sector is to have a product that is net zero, fully recycled, and circularity, sustainability aspects all come with the one pellet that we hope to sell to our clients. So that is the real push. I think, I'll end by saying that we really need to get the economic incentive programs correct, because if you look at a company, it's no different than you do your personal finances. A lot of people look at these incentive programs as corporate welfare, and I would push back against that wholeheartedly, because the reality is that we may get an incentive that is minuscule when it comes to the overall investment. And the payback that the economy and the government and the citizens of Canada get on a 30 or 50-year project is magnitudes higher than the incentive that you would get upfront. If you were to invest personally, if you wanted to retire at some point in your career and someone is offering you a 5% return on investment for one location or a 13 or 15% return on investment in another, you are going to go take your investment where you're going to get a higher return. We are a company. We are publicly traded. We want to be sustainable. We want to be profitable. It's no different than individuals who make their own personal decisions. And Canada can be a leader when it comes to some of the incentive programs and getting that investment.
And thanks for that, Mike. I know that there's been a few mentions along the way of market opportunities. I'm going to throw it to Oliver as the author of the white paper on decarbonizing the sector. I'm interested in hearing your views on the market opportunities that you feel will likely constitute the roadmap to decarbonization. So what are the most important and which are the biggest challenges?
Yeah, I mean, I think a lot of the panelists have already touched on it. It's, realizing that there's a growing and sort of leveraging that growing sort of size of market that's saying we want, mentioned for the 100% recycled plastics, we want to be able to say that our scope 3 emissions are entirely clean. And I think I mentioned in my presentation, there are a growing number of international groups that are sort of coming together and saying, we're gonna sort of make commitments, we're gonna sort of leverage our sort of larger buying power and say that this is the products we want to prioritize. We see the benefit both obviously for the emissions reductions for our own ESG requirements, but also increasingly obviously consumers themselves wanting to be able to have confidence in lower emissions products, recycled products, and the like. I mean, I also want to touch, and I would steal my question slightly and touch back on a couple of things that Sarah and Mike mentioned, and one of them is, and I think from a CEC perspective, we've certainly seen Budget 2023 as a good response. The hydrogen CCUS tax credits in particular, I think well aligned with chemistry as an industry. But it's things like the electricity grid. We talked at the top 92 or 84% clean overall in Canada and higher than that in different provinces. The ability for companies to come in and plug and play and just say, look, this grid is building out capacity, it's clean. You don't really have to worry about this. You don't have to think about necessarily, obviously there's some technical requirements for on-site generation in some places, but also to not have to necessarily go behind the meter or behind the fence for clean electricity and for things like hydrogen production and others. That's why things like the clean electricity regulation are so important, because it just provides that sort of certainty to say, I'm going to come into Canada, the electricity taken care of, and I can go and worry about the things that I'm worrying about. And there's obviously other packages of incentives and opportunities for companies to succeed. Certainly Inflation Reduction Act has been a game changer. We hear it from every heavy industry sector, not just chemistry. But yeah, and as Mike mentioned, there's still some details to work out on that. But recognizing that something like hydrogen right now, the production tax credit in the US is more competitive by some measures than Canada's investment tax credit and things like that. So some challenges, but a lot of opportunities as well. And I do think those kind of larger scale infrastructure sides of the piece are really important. And I think Michael also mentioned the trunk line. We've had a lot of experience, we've had a lot of time building pipelines to transfer oil and gas. And now we need to transfer lots of carbon, and the market for carbon is not the same as oil and natural gas. It is not, does not have the same commodity value. And so, what's the role of how we build out a kind of national infrastructure that, again, can be plug and play, can bring in investment to say, this taken care of, that's taken care of, and you come in and you do your thing. I think is sort of going to be a growing sort of concern, should be a growing priority. And the final point I think is, and again, I think I flagged it, Mike also flagged the sort of the length of these facilities. We are one investment cycle from 2050. It is in some ways wrong to think of net zero 2050 in a lot of these heavy industries. It's actually a decision that you're going to make in the next year, 2 years, 3 years. We are in this absolutely critical window that if we miss this window, you can pray all you want, you're not going to get to net zero 2050 if you don't have a time machine and start building a facility 5 years ago. It's just not going to happen. So I think people need to think really, policymakers, and also obviously bringing in, making sure that this window of time is maximized for Canada, both for emissions and also obviously the long-term economic benefits that provides.
Awesome, thank you for that. I'm going to throw the last question to Bob before I turn it to the Q&A. I think there are some who would tell you that government, and by extension the taxpayer, should be the ones paying for the kinds of technology and innovation, turnover in capital infrastructure that we've talked about over the course of this webinar. We also discussed how essential it is to decarbonize the chemical industry in Canada. At the end of the day, are these folks right? Does the government have to pick up the tab? And aren't we seeing signs of this in the US already, noting the response of our federal government in its most recent budget?
Well, I think that's a perspective that many seem to hold, but I don't think it's in keeping with reality. Mike spoke at length about this. The role of government is to create the conditions where companies do want to invest and are willing to invest here. We have most of the tools, many of the tools, better tools than nearly every other jurisdiction in the world to decarbonize our sector. What we don't have is a competitive investment environment. Look, we've also had a long history at different times in Canada and the US of governments basically taking all the risk on and then putting that on the public purse. And that's not what's happening here. You're talking about either credits, tax credits, which ultimately you got to build, you have to operate, you got to sell product, you got to make profit, pay taxes, and then you get a chance to pay a little less tax. So you either got a tax credit that ensures the facility is actually operating and delivering a product the market wants, or likewise, a production credit when we think about what's being proposed for batteries, right? You have to build it. You have to have a customer that wants to buy it. When you sell it to somebody that actually wants it, you're going to get a credit to help make this investment more attractive to take place. So I think the approach the governments, both in the US and Canada, are taking are much more sophisticated in the past. You see this also with Alberta's APIP program. There was zero risk to the taxpayer and the public purse, and that's ultimately the test of what you want. We haven't talked about it here. The last thing I think really important to stress, I'll talk fast. We're talking a lot about the new investments, the new things that could happen. We also have to keep in mind, though, the existing facilities. And we're talking about going to a carbon price of $170 a ton by 2030. If we don't, back to what have we attracted, 15 billion of investment over the last 20 years, if we don't figure out how to get the investment conditions right, we don't want to contemplate the future where these industries cannot, not just chemistry, but other industries cannot operate. Ollie gave the example of China. You make a ton of methanol in Canada, the same ton of methanol in China is 8 times as much greenhouse gas. If we overburden that sector here and not provide it that opportunity, we are doing nothing to address the global climate challenge. So there's another big piece here that governments have to think about as well, is how do you marry the important carbon price signal, but again, make sure that you've created conditions where companies can and want to invest. And avoiding the carbon price is not an investment signal, because you can avoid it in many different ways, and we don't want the one way that most organizations will choose to avoid the carbon price. It's not going to be a popular outcome.
Thanks for that, Bob. And we've had an extremely active Q&A. So I'm going to try and get through, I'm going to maybe do 1 or 2 and try and condense a few of them that have come in on the same topic. So Sarah, Nova also has an ambition to be a top 30 company in Canada by 2030. How does decarbonization and circularity support that?
That's a great question. First of all, we know that consumers are wanting more sustainable products. And I know I saw a question in the chat around, well, are consumers willing to pay for decarbonization? And I think Mike and I could have a very good discussion on what the status is there, but we certainly know that plastics play an important role in society, and consumers want those to have more sustainable attributes. So when we talk about our strategy of growing 30% sales from recycled polymers, we're growing our business. And as we grow our business, we're increasing the opportunity to become a more profitable company. So that's one way in which we are contributing to becoming a top 30 company in Canada. When we look at decarbonizing our operations, to Bob's earlier point, this isn't about environmental policy anymore. It is an expectation, we believe, of society that industry is going to decarbonize. We believe we're past the point of whether or not we should do this, and more to the point of how do we do this effectively? How do we do this in a way that is accretive to the corporate's bottom line? So that's an important part of the strategy for the future, in our view, not just for Nova Chemicals, but for all heavy emitters. And there's lots of things that are going on in the company that will end up being also positive to the bottom line from a decarbonization perspective as well. Not all moves are requiring the same level of support as the big levers to decarbonization do. So that's an important thing. And finally, there's a link to sustainable products. And I mentioned that earlier in my comments, but I didn't really get into the details. Ollie mentioned it at the beginning. Plastics are necessary for the future of a decarbonized world. Now, we don't make the product that goes into wind turbines, which is a very popular example, but we sure do make products that protect the longevity of food, and that can be reused again in food packaging through recycling, as an example. So those types of growth opportunities as we continue our journey as a company will all contribute.
Thank you so much for that. And on that note, I'm just going to throw one last question to Mike. So what is the role that chemical plays in advanced recycling for Dow?
So good question. So right now we have a mechanical recycling. I won't say that we joint venture with a lot of companies, and we've got a mechanical recycled feedstock that we also market, similar to Nova. I think our position is that in order to tackle the plastic waste and the sustainability aspect that you're seeing around the world, I think we're pivoting more to what we call chemical or advanced recycling opportunities. We've got a number of projects around the world where we have partnered with technology companies that are looking at taking a broader variety of plastic waste and turning that into a feedstock within we can then slipstream back into the front end of our facility using as a feedstock to make recycled plastic. The difference is that you have different technologies around the world. I know we're getting short on time, so I'll try to give a very quick answer. But in Europe, typically Dow, we crack naphtha. We crack an oil-based product. So the type of raw material that goes into the front of that facility has to be different than what we do here in North America, where we crack natural gas, we crack ethane. We've got facilities that are looking at using pyrolysis, gasification, and what we hope to do is have those facilities taking on a wide swath of typically hard to recycle plastics, getting a feedstock out of the back end that then we can then move into this potentially our new facility in Canada. Right now we're focusing on the decarbonization, but basically I can assure you that we will be having a recycle component coming out of the facility down the road, because as Sarah alluded to, it is what our clients and what the global world is looking for. We're looking for circularity. We're looking for a product that can be recycled over and over again. In perpetuity, basically, is a perfect example of circularity. And some of the advanced recycling technologies that we are investing in Europe and the United States and hope to look at and to, I guess, implement in our facilities globally, they are looking at these materials that can be recycled in perpetuity as you take a polymer, which is a plastic, a complex chemical, and you turn it into its base monomers. So basically you, through heat and pressure and different types of technologies that are out there, we are breaking it down into something that can be reused again, as I indicated, potentially, almost in perpetuity.
Well, sadly, that's all the time we have. I want to thank each of our panelists for their contribution to this important discussion. And I especially want to thank our viewers. I can't believe the amount of questions that we got submitted. So for those who we didn't get to, we're going to give our panelists some homework to do and see if we can provide answers to you in writing over the next coming days. As mentioned at the top, we were recording the session and we'll be sending each one of you a link as well. So feel free to review and share it with your colleagues. Likewise, if you have any additional questions after or comments, we'd love to hear from you. So please do not hesitate to reach out. Once again, thank you for joining, and we look forward to seeing you all again soon.